Hey, y'all, here for a second benchmark review, and I'm just going to go through a select few of problems here on the second benchmark review that I gave you. I'll do some polygons problems, and I'll do some circles problems, because those aren't on the first one. If you want to look at anything else from Unit 1, you can go back to the review 1. Again, just like last time, fast forward if I'm going over a problem that you don't need help with, and skip through and just do the ones that you need help with. So I'll start with number 14. We're finding each interior angle of a regular polygon is 120. We want to know how many sides the polygon has. So a quick way we can do this is, in a regular polygon or any polygon, an exterior angle is supplementary to the interior angle. So I can find the exterior angle by doing 180 minus 120, and that gives me 60 degrees. And I have a formula for the number of degrees in one exterior angle for a regular polygon. That's 360 over n, the number of sides, and that's what we're actually looking for here. And we know that that should be equal to 60, because that's how much one exterior angle measures. So if we do a little algebra here, we can find out what n is. So I'm going to multiply both sides by n and get 360 equals 60n. Divide by 60 and get n equals, and I need to do a quick calculation here. Hold with me. It's going to be 6. So this guy has 6 sides. Which makes it a hexagon. So again, I just knew that an interior and exterior angle are supplementary, adding up to 180. I found out how much an exterior angle was. That's 60. Put it into the formula here, where we do 360 divided by the number of sides equals one exterior angle. In this case, we know the exterior angle is 60. Do some algebra and find that n is 6. Go up top here to 15. We're finding angle B and angle H are congruent. We want to know angle B. I don't know either of these, but I know they're the same, so I'm going to call them both X. And I'm going to count here. I have 1, 2, 3, 4, 5, 6, 7, 8 sides. So I can find out the total number of degrees that the interior angle should add up to, because I know something about all the interior angles, and that is 180 times n minus 2. In this case, n is 8. So the interior angles of this polygon should add up to 1080. So all of these angles should add up to 1080, so that's what I'm going to do. I'm going to add the two x's together. That's 2x. I'm going to add all of the rest of them together. So 114 plus 134 plus 142 plus 138 plus 137 plus 135. That gives me 800. And that should add up to 1080, and I can just solve this equation. 1080 minus 200 is 880. I'm sorry, I want to do 1080 minus 800 is 280, and divide by 2 and get that x is 140 degrees. We're looking for angle B. We called it x. So that means the measure of angle B is 140 degrees. It also means that the measure of angle H is 140 degrees. Let's go down and do 16 and 17. 16, I have that each interior angle of a regular polygon. That's important to know what's regular. That means all the sides and angles are equal. Exterior angle measures 5 degrees. We want to know how many sides it has. This is very similar to number 14. We know that 360 over n equals 5. Multiply both sides by n and divide both sides by 5. 360 divided by 5. That means that this polygon has 72 sides. Remember, n means the number of sides. Over here, this question is kind of incomplete. We should know that these are regular polygons. Those directions might have just been missing. So we can find the measure of an exterior angle of each of these polygons. If we draw that there, we get that exterior angle and that exterior angle. And those two exterior angles together should make up x. So this guy has 5 sides, so 360 over 5 will tell us how much that exterior angle is. And that's 72. Over here, this has 6 sides, so 360 over 6 will tell us how many degrees in that exterior angle. And that's 60 degrees. So x is both of those together. If I add both of those together, I get 132 degrees. Got a couple more polygons questions. If I want to find the measure of an interior angle of a dodecagon, the measure of one interior angle, and we should also know that this is regular. Again, the directions are incomplete. The formula is 180 times n minus 2 divided by n, not 2. A lot of people like to divide by 2. It's divided by n. So a dodecagon has 12 sides. We plug 12 in for n in both places. We get 180 times 10 divided by 12 is 150 degrees. So every interior angle of a dodecagon is 150 degrees. Down here, we have that DCQ is 3x plus 6. We know that this is a regular octagon. Angle DCQ is an exterior angle of an octagon, so we can figure out how much that angle should be. 360 divided by the number of sides, which is 8. And that means every exterior angle is 45 degrees. So 3x plus 6 equals 45. Subtract 6 from both sides. 3x is 39. X is 13. And that's what we were looking for in the question. We're looking for x. I'm going to skip these problems. These are parallel lines problems. That's the next unit. And then some of these other problems are from Unit 1 material. So if you need help with that, again, go ahead and go back to review number 1. I'm going to do some of these problems here, some of these circles ones. I'll do maybe a handful of them that cover things that will be on the test. For instance, I've done 36 and 39 in class, I know that. And again, if you need help with any of these at any point before the test, just go ahead and ask me in class. I have no problem showing you that. I like to do 37. 37, we get the measure of this angle. The angle that's 31 degrees is formed by these two chords. And that is an inscribed angle. Its vertex is on the circle and its two sides are chords. So that means that this arc right here is 2 times the size of that angle. So that means this arc is 62 degrees. We're looking for x. This chord is a special chord. It's a diameter. It goes through the center of the circle. A diameter cuts a circle in half, makes it a semicircle. So we know that this big arc here is 180 degrees. In order to find x, we take that 180, subtract the piece of it that we already know, 62, and we get that x is equal to 118 degrees. So it looks like a complicated problem. Really, it's just a subtraction problem. I'd like to do number 40 as well. I have this tangent segment here. I have this secant segment, and I have a diameter, a chord. I covered up there. This guy is 3. A tangent and a diameter make a right angle. This radius is 2, so that means this radius is 2. The whole diameter is 4. And this is a Pythagorean theorem problem. I have this side 3 squared plus 4 squared equals x squared. So 9 plus 16 equals x squared. Take the square root of both sides. We get x is 5. So it's key to remember that a tangent and a radius, or a tangent and a diameter, are perpendicular, which means they make right angles. So this is a right triangle, and we can use the Pythagorean theorem to find out x. I also like to do 41. Again, 38 I think is a problem we've seen in class. If you have questions on it, please don't hesitate to ask. 41, I have a big arc labeled, small arc labeled, and an angle labeled. So that's going to point me in the direction of big minus small over 2 equals the measure of an angle. So I'll plug in everything I know here. The angle is 2x plus 44. The big arc is negative 10 plus 20x. And we'll subtract the small arc 10x minus 20. And I'm running out of space here. And that's all divided by 2. To get rid of the 2, we multiply both sides by 2, so we end up multiplying this whole thing by 2. So 2 times 2x is 4x. 2 times 44 is 88. I can lose the parentheses over here. But here I have a minus sign, and this is crucial. I have to multiply this minus. There's a minus 1 there, times everything in this parentheses. So I have to multiply minus 1 times 10x, which is minus 10x, and a minus 1 times negative 20, which makes that positive 20. Now I can simplify the right side. Negative 10 plus 20 gives me positive 10. 20x minus 10x gives me positive 10x. And I just solve this equation for x. I'm going to subtract 6x, or 4x on both sides and get 6x here. Subtract 10. And I divide by 6, and I get that x, and I'll come over here. X is 13. And I wanted the measure of angle B, so I'm going to go ahead and plug back in for x here. 2 times 13 plus 44. 26 plus 44. Angle B is 70 degrees. I'd like to do a couple more problems. I'm going to choose just about 3 more. I think this one right here is important. The circumference of a circle A is 49 pi, and we want to know or I'm sorry, we want to find the circumference, and we know that A, which is the area, is 49 pi. So in order to find the circumference, we start by using the formula 2 times pi times the radius. We need the radius. Well, we know the area, and we know the formula for area is pi r squared. We know A is 49 pi, so I'll plug in 49 pi for A. These pi's cancel, and I get 49 equals r squared. If I square root both sides, I get that r is 7. So I can plug back in here. The radius is 7. 2 times pi times 7. 2 times 7 gives us 14. We're leaving in terms of pi, so I leave pi alone, and my circumference is 14 pi. So a little bit different here, because normally when we have area involved, we're given the radius. This time we're given the area. We want to find the radius. So I'd like to do number 46 and number 48. And any of the other ones that you need help with, absolutely ask me during class this week. Here we get a circle, and we know the ends points of the diameter are 17, negative 12, and 5, negative 4. And we want to write the equation. So the equation of a circle is something we can always start with if that's what we want to end with. We start with the general form. And we have the diameter, the endpoints, so we need to find the radius and the center. Well, the center is the midpoint of the diameter. So if we use midpoint formula, we can find the center of the circle. And using midpoint formula, I can add 17 plus 5. That gives me 22. Divided by 2 is 11. Negative 12 plus negative 4 is negative 16. Divided by 2 is negative 8. So there's my center. There's my HK. I can go ahead and plug those in. And this minus minus is going to simplify to a plus. Last thing we need is r. Well, an easy way to find r is to take one of these points and plug the x and y in for x and y here, simplify the left side, and we'll get r squared. So I'm going to plug 5 and 4 in. I'll plug 5 in for x, plug negative 4 in for y. I'm going to simplify till I get something on the left that equals r squared. 5 minus 11 is negative 6. Negative 6 squared is 36. Negative 4 plus 8 is positive 4. 4 squared is 16. And I get r squared is equal to 52. I can keep going and find the radius, but I really can just plug back in for r squared. R squared is equal to 52. So I'm going to take what I got from plugging my center in, and I'm going to replace r squared with 52, and now I have an equation of a circle. Always make sure you plug r or r squared back in, and that when you have your final answer, there's a y and an x. Okay, so we need to take 5 and negative 4 back out, and we need to leave x, x, and y, y. Okay, last one, number 49. Looks like it might be pretty difficult. There's not a lot of information given, but if you take a second, I think that you'll see that this is a problem you can solve pretty easily. I have an angle here formed by a tangent and a secant, and it forms this arc and this arc, and that leads me to a angle equals big minus small over 2 situation. You might say, well, we don't know either of these arcs. Actually, we know one of them because this diameter cuts the circle in half. This arc is 180. That's the big. We know the angle. We can find the small. So even if you don't know where this is heading, it's still a good idea. It'll help us find out another piece of the puzzle. So my angle is 52. My big is 180. I don't know small. Multiply both sides by 2. That's an S, not a 5. Subtract 180. So my small arc is 76 degrees. That's this guy over here. Now if you notice, this angle is an inscribed angle. So, or I'm sorry, not an inscribed angle. I need to correct myself. It's a central angle because it's formed at the center. So the arc and the angle are the same. So if this arc is 76, that makes this angle 76 as well. And this angle, that's 76, and the angle we're looking for, x, are supplementary angles. They're a linear pair. So x is 180 minus 76, which is 104. So x is 104 degrees. So I chose some of these problems to do, and I chose some of these problems not to do because I know some of them are more difficult than others, and some of them are more important than others. So again, if I didn't do a problem you needed to see, just ask me in class, ask me after school, and good luck to you.